Hello guys, today we are learning all about alkanes, and under this topic we are covering up its introduction, nomenclature, and its uses. So, what are alkanes? Alkanes are saturated hydrocarbons. We have here an example of a structure of an alkane. Alkanes are saturated, meaning they only contain one single bond. And hydrocarbon, meaning they are chemical compounds that consist of carbon and hydrogen atoms. Next, we have the chemical structure of alkanes. The chemical structure of alkanes has three types. The first one are linear alkanes. Linear alkanes have carbons bonded together in a chain-like structure, similar to a snake. Each edge represents a carbon. Hydrogen atoms are not visible in the structure because the carbons are assumed to be octet form. Second are branch chain alkanes. Branch chain alkanes are alkanes with attached alkyl groups such as the ethyl group or a methyl group, attached at the main branch or at the parent alkane. These branches are attached are called substituents, or an atom or a group of atoms attached on the parent chain. Third are cyclic alkanes, or referred to as cycloalkanes. Cycloalkanes are arranged in a form of a ring. Naming of alkanes. First, I will draw a structure of a linear alkane. The first thing you should know is how many carbons are there in the structure. It does not matter whether I start my counting from left to right or right to left because there are no substituents. So I start my counting left. So this will be the first carbon, the second, the third, fourth, and the fifth carbon. In all, there are 5 carbons in the structure. The name of the structure is called pentane. Pent is a prefix used if there are 5 carbons in the structure. There are some prefixes that are used depending on how many carbons are there in the structure, such as met. If there are only 1 carbon, eth, for 2, prop, for 3, for boot, pent, for 5, hex, for 6, pent, for 7, oct, for 8, non, for 9, dec, for 10, undec, for 11, dodec, for 12, tridec, for 13, tetradec, for 14, pentadec, for 15, and so on. The suffix "ane" is used because the structure is an alkane. So let's make another example. So first thing to do is count the number of carbons in the structure. So 1 carbon, 2 carbon, 3 carbons, 4 carbon, 5 carbon, 6 carbon. After counting the carbons, know first the prefix, which is hex, because there are 6 carbons in the structure. Next is the suffix. Ane will be the suffix because this structure is an alkane. So the name of the structure will be hexane.
So, in naming an alkene, we have 4 terms that we have to make in mind, which is the locant, prefix, parent, and the suffix. Locant is where the substituent is located, while the prefix, what are the substituents. Parent is the number of carbons, and suffix is the highest bond. Example of the parents are the met, et, prop, and other more. While the highest bond is the single bond, which is named as the suffix ane. Now, let's move on to an example. Here. First, we must find the parent. As I can see, this skeletal structure is the longest carbon chain. So, we number the carbons. As we number the carbons, we can say that it is a pentane. But we have a problem. What's this? Well, naming a skeletal structure considers that. We can name this part as as a medium, and the 2 is where the number of carbon which it attached. So this is 2-methyl pentane. 2 here is the locant, the prefix. Now, moving to a more complicated example. There. Now, first we must find the parent, which is this. Now, we number the parent. Now, we can say that this skeletal structure is hexane. Now, we name the substituent. There are 2 substituents as we see on this skeletal structure. So, we will write 2 and 3 and the name of the substituent is methyl. Now, there are 2 methyl, so we will write times.
Before, we identified cycloalkanes as saturated hydrocarbons that forms a ring-like structure. So the name of the structure is a cyclohexane. So how did I name it? Like before, we first count the number of carbons present in the structure. So we have 1, 2, 3, 4, 5, 6. We have 6 carbons in all. From our list of prefixes, when the structure has 6 carbons, the name will be hex, for 6 carbons. We identified the structure as a cycloalkane, so the suffix is always ane, and for every cycloalkane, we add cyclo before the prefix. We add all together the prefix and the suffix, and we have cyclohexane. Here's another example. Now we have a substituent attached in the cycloalkane. The first thing to do is to find the parent chain. The parent chain is the longest carbon chain, which is this one. When it comes to cycloalkanes, the longest chain will always be in the ring. Otherwise, there is a longer chain in the cycloalkane. In this case, the cycloalkane will be the substituent. For example, there are more carbons than the ring, so this becomes the substituent. After finding the parent chain, we start numbering the carbons in the longest chain. The first carbon will be at where the substituent is. So this will be the first, second, third, fourth, fifth. In all, we have 5 carbons, and the structure is a cycloalkane. Named as cyclopentane. Next, we name the substituent. Like we did in naming the parent chain, we first count the number of carbons. In this case, we only have 1 carbon, so we name it as met for its prefix. For its suffix, we name it as il because it's a substituent. Next is its locant, which identifies where the substituent is located. In this case, the substituent is located at the first carbon, so the locant is 1. And lastly, we put all the names together. We have 1-methyl cyclopentane. So that's it for today's video. Thank you for listening. Hope you learned something about alkanes, and always remember to subscribe from this channel.